All right, my name is Luis Pabon, and I work at Portworx, and I'll be speaking about gRPC and what happened when, a little bit of history, I'll talk about in a little bit, but it's how we went through a journey in Portworx, trying to determine what method to create an API, and then how to secure it for our developers. My name is Luis Pabon. Like I said, I now work in a company called Portworx. What we do is we do storage management for Kubernetes. And before that, I also worked at CoreOS and we had storage. Yeah. And then I also participate in CNCF. I'm one of the technical leads there. And I also been participating in Kubernetes since 1.3. So it's quite a while now. I also been participating in a project called CSI for storage since its inception, about a year and a half ago. So a little bit of history. At Portworx, we had a storage system that we deploy in Kubernetes, and it manages your data, manages your PVCs, your PVs, and your applications, and how the data gets moved from one cluster to the other, gets snapshots and things like that. So one of the things that we wanted to do is provide our customers with a model, easy consumable model for an SDK that they can then integrate with their control planes. So if they don't want to use the Kubernetes control plane, they can use our SDK and put directly into their control plane for their users and things like that. So what we did was we have an open source project called Open Storage SDK. And again, all these slides are on my GitHub. I'll have a link at the end. So you can always, there's gonna be a lot of information here. It's gonna be like a big torrent of information in gRPC. So consider this talk more like an overview, then you spend the time looking at each one of the examples. So anyway, the Open Storage SDK, we have it now available, and it's a gRPC-based SDK, and we have it also that is supports security, which is what the talk is going to be about. So, security models. First, I had to admit that I knew nothing about security. I've been doing storage for almost 20-something years, and I didn't know anything until about almost 2 years ago. And I was able to talk to a good friend of ours, Eric Chiang from CoreOS, and he gave me the lowdown on how to actually do security correctly in a gRPC service. And that's pretty much, I'm taking his ideas that he told me and just displaying it through the community. So first is authentication. What is it? Authentication itself is a way to identify that who you are to a service. Not only who you are, but who you say you are is actually who you are. They could be trying to fool the system to say I'm somebody else, and the system may say, no, you're not that person. So there needs to be a way to identify correctly that the person you say you are is actually who you are, right? Second is, once that you are authenticated, the system says, okay, I trust who you are now. The second thing is that the system has to say, what are you allowed to do? And that's where authorization comes in, right? You may be trying to access an API that you're not allowed to use. You may be trying to access a resource that you may not be allowed, or maybe you are allowed. So the system uses these models to to enable your access to certain APIs or certain resources. All right, so let's talk first about authentication. So does anybody know what this picture is? Come on, this is way back. This is way back. Anyone? Sneakers. That's right. That's like an early 90s, 91 maybe? Yeah. So this Sneakers movie is all about security. So if you want to watch a really stupid movie, you watch this. It's kind of funny. It's a funny movie. But anyway, in that movie, they try to deal with authentication. The guy goes to the door, and he actually has to say the words, and the computer then has to determine if that person is who it is. All they did was to try to get in was record the person saying those words and play it back through the tape, right? And they were able to get in. So how do we do authentication today, right? So one of the things that we could do is we need to discuss how is it that we're going to save those passwords. Everybody does login and passwords, right? The systems. You log into a system, you send in your username, you send in your password. Then your gRPC service can then take that password, take that information, and save it somewhere securely, right? No. And this is major mistake that I was trying to make, and Eric said, absolutely no way should you ever touch a password. What you want to do is verify the tokens. That's it. It is not your responsibility to manage passwords. Password management is a quite complicated system. You want to pass that off to somebody else. You want to leave that up to another system and leave your gRPC service as simple as possible. And all it needs to do is verify a token. And what we're going to discuss what a token is in a second. Okay, but does everybody understand that? That your system, once you get gRPC service, all you need to do is verify tokens. No login system or anything like that. So, authentication then is used through a token, which I've defined, but what is a token? A token that we used is the normal token that's used all throughout the internet, and it's quite a standard. It's called the JSON Web Token. And a JSON Web Token is really 3 parts. It has the header, has claims, and a signature. Anybody familiar with the JSON Web Token? Okay, good, because I don't have to go too into it. But in this JSON Web Token is what we will be using in our gRPC authentication system. And then we have what's called a token authority. So those who are new to JSON Web Tokens, somebody needs to issue that token to you. So normally what happens is that you go into a website, maybe that website says you can log in through Google or you can log in through Facebook, right? And you get redirected to those websites. Those websites do your logging system with your password or your 2-step verification. Once they decide that you are who you say you are, they give that token back to the website you're trying to log into, okay? And that's how most of the internet works. Now, we have 2 methods of generating tokens for gRPC services for trying to make things simple. One is an application creates a token for you. So you have some type of agreement between the gRPC service and the token authority. The gRPC service says, I only trust this one token authority, and the token authority then generates tokens. You as a user somehow get the token from this, we're not going to spend that time here. Somehow you get a token from this application. It could be your own internal website that you create yourself or something else. And that generates a token for you. Use that token and you pass it into your gRPC service. And that's okay, but there's another one called OpenID Connect. Anybody know what OpenID or IDC is? Just a few. Okay, so that one is it's a standard on how a service communicates with a token authority, okay? And that service says, hey, token authority, I need your public key to be able to verify the tokens that you give to me. And the user can then go to that OIDC system, get a token from there, and use that to be able to get services from the gRPC service. We'll dive into that in a little bit. So, again, if you're new to JSON Web Tokens, how do you create one? Here's just a simple Golang pseudocode of how you create a JSON Web Token. So again, the JSON Web Token with 3 parts. You got the header, you got the claims, and the signature. Now the claims is just a map, all right? So in that map, there's you can put whatever you want, really. It's just a JSON map. The OIDC standard has a set of required values in there. For example, for the expiration of a token, the token has a certain lifetime. Maybe you could give somebody a token for a day or an hour or 5 minutes and so on. And then the server can then verify that token is still alive. It still has its lifetime. You got the issue at time, the IAT. You got any roles or anything like that that your system can read. Email, and the subject, this SUB. SUB is a very important one, is the unique identifier for your account, according to the person who created the token, okay? All right, so I also have, again, like I said, I have links. So I have that link down at the bottom, and you can see an actual running example to create tokens. So let me go to my time, see how I'm doing on time. Okay, so OpenIDC, the project that we created in the open storage SDK, we wanted to make sure that it supports not just a few tokens, because we don't know who's going to create them, but also can support thousands of users. And to do that, we wanted to support OIDC. So take an open source project like Keycloak, which is from Red Hat. What it can do is it installs as a container into your Kubernetes system, and then it provides an OIDC compliant interface to a service. But it itself can have users in a database, and then users can go to Keycloak and log in, username, password, and get a token. Or Keycloak itself can connect to an LDAP service. Okay, and through the LDAP, it can actually do this thing called mapping. So it maps information from LDAP into your token that they require for your gRPC service. So that way you can take groups, roles, or anything like that from the LDAP, and then Keycloak can then map that information into your token, give that token to the user then gives it to the service, and then that service understands who you are, what can you do. Okay? Any questions on that? Any questions? All right. So if I start asking you questions, you should be able to answer. All right. Okay, so this is the part of the talk that we're going to start deep diving into the code. So hopefully I'll try to keep it lively so you guys don't fall asleep. So, but to me, this is the coolest part, but maybe some of you think code is kind of boring. But anyway, what we do in gRPC is that we pass the tokens in what's called the metadata of the context. So if you've done JSON Web Tokens in REST calls, what you normally do there, which has been a standard, I don't know how many years, is that you pass it in the header of the REST call in a header called authorization, right? So you kind of do the same thing. Think of metadata for a gRPC call as the header for a REST call, okay? So in this one, for example, in Python at the bottom, all we do is we create a method, MD, or for metadata. We put in a tuple in there with the token, and then we pass that into our metadata call in Python, and it goes across to the gRPC service. gRPC service, we're gonna go actually discuss in a little bit how it does it, but then it goes ahead and extracts that token from the metadata. Okay, how am I doing on time? Just making sure. Okay. All right. So the client side, as you can see, is super easy. All I need to do is get the token from somewhere, magical place. It was handed to me. I then insert it into the metadata, and I'm off. So the client is quite easy. The difficult part is how do you connect all these things together in the server side? So on the server side, actually, before I go into this, how many of you are familiar with gRPC, first of all? Okay, good, quite a few of you. And how many of you use interceptors in your gRPC? All right, good. Excuse me. So an interceptor in a gRPC service is just like middleware is for a Python, like for example, a Whiskey program, okay? So all it does is as a request comes through, you can set up your gRPC server to run through a set of interceptors before it actually gets handled by the handler. You are in complete control of the order of the interceptors as it goes through, all the way down to the handler, okay? So what we're gonna do is we're gonna use that power of the interceptors as a model of adding authentication, authorization, and anything else we want for all our services from now into the future, right? That's really the power of it, that you are adding all this to any service you create that exists now and any future ones, because they'll all go under the interceptors, okay? Any questions? All right. Okay, so here is a very simple interceptor. Okay, they all have the same parameters, all the interceptors. And we have one, each one of it gets the context. And where is our token? Our token is inside of that context. Well, we'll be going into that a little deeply a little later. But right now, we're just looking at how an interceptor works. So in here, what we do, in this interceptor specifically, it takes the context and inserts to it some data. The really nice thing is that when you set up your gRPC service, you set up the order of your interceptors. So you could have the top interceptor kind of look at some information, analyze, and then take the output of that analysis and place it in the context for other interceptors to consume, okay? And that information is passed through the context, okay? So I can put in the value any data. I can put a whole object in there. I can put a string, a map, a struct, whatever I want, okay? So then other interceptors later can pull that information out of the context, knowing that if I got called, it must have been done already, and then I can continue the analysis, okay? And again, really important thing, and this is what makes this gRPC authentication and authorization specifically possible, is that info object, gRPC unary server info, has the method that you're trying to access, okay? So with that information, we'll be able to, one, look at the context for authentication, and two, look at the info full method for authorization. So let's take a look exactly how we're going to do that. All right. So first, we need to figure out how to set up the server with the interceptors. As you can see here, very first thing we do is create an array of the interceptors. Then we go ahead and append to that array. I could have appended much more, but just for this simple example, I appended only the simple interceptor that I showed you a second ago, and then a second one called GRPC auth unary server interceptor, and it wraps around an interceptor that we're going to talk about in a second. So that is a helper function from that package called Go GRPC middleware auth that understands how to do authentication and authorization. Okay? So when you wrap, and then you wrap this function coming up. Here, this function doesn't have the same number of parameters. You notice that? This function only has that one parameter, the context, because that's all you need to be able to authorize a user. Okay? And again, this is being wrapped by this function here. That's why it doesn't have all the parameters. I mean, you could create your own interceptor with authentication from scratch if you want, but this helper function makes it a little bit simpler. So as an interceptor, you come in, you get called from some context gets passed to you, then gRPC auth from MD pulls the token out of the context. Okay? Does that make sense? So now with this call, all your functions are being checked for the token as they get called. Okay? And then you can verify the token with whatever method you need to do to verify it. And again, like I said before, we have a little example links here, and I have examples of how I did this in the Open Storage SDK, so you can look at a running real example that we use today. So, any questions on this before I continue on interceptors? And you can see here also, one second, here we return permission denied for any, that's a gRPC error code. So when we return permission denied, which is a known gRPC error. The other side will then can actually look at that error and see that it was denied. Go ahead. With the stream server, it works with actually any gRPC model. When you first connect the gRPC server, right, you are trying to get access to the API first. It has to go through the interceptor. And then after it goes through the interceptor, then it goes to your handler and sets up the binary connection. Okay? Any good questions though? Any other questions? All right. All right. So I just want to put out here some Golang verification libraries. So like I said here, this is where the magic is a verify function, right? So there's a couple of methods. If you're verifying a self-signed token, meaning from an application, you can just use the normal JSON Web Token verification libraries, and then you verify through either a public-private key or a shared secret model, and you can use that. And again, I have the examples there, so you can look at the code. That's all open source. And the second model is to use good old CoreOS code, right? And I keep doing. Anyway, the CoreOS code that has very good OIDC compliant libraries. So that one's actually really nice, as it's written by Eric and others. And what it does is that it goes, when you try to get a token, when tokens coming through the interceptor and it hits the library to verify, the library may say, oh, I don't have the public key yet to verify this token. I need to go get it. So that's a really nice benefit. So with the raw JSON Web Token model, you need to supply the public key to the system so they can verify your tokens. But with OIDC, it does this automatically. It says, oh, I don't have the information. Let me go to my OIDC server, get the public key from them automatically, and then I can verify this user. So the setup is actually much simpler of your service. You can just tell it, this is the OIDC service that you want to use. Just go ahead, get the public key, and it's all done automatically. So again, the OIDC is a much powerful model, but if you want to do just very simple applications, the JSON Web Token model, it's okay. We actually, in our open storage SDK, we decided to use both. And what we do with both models is that we support them at the same time also. And our Portworx system, what it does is that when we turn on security, it doesn't trust anything. Okay, it doesn't trust itself. So we are you could say a daemon set in Kubernetes. So for nodes to talk to each other, they need to create tokens to talk to each other. So the entire API is closed for everything. And so when it sends a token to each other, we have a set of shared secrets that we use to create tokens, and that's how we communicate node-to-node information. Okay? All right. Any other questions? Yeah.
Why did you decide to use both?
Oh, okay. Yeah, good question. So we decided to use both. One was for the node-to-node communication, for application communication. We found that it was much simpler for like operators that we throw in Kubernetes to be able to automatically get access to the SDK through a simple token, right? Maybe you get a 1-month token or a 1-week token for a software-to-software communication, right? But when it comes from user communication, we needed a method that was much more dynamic. And to do that, we needed OIDC. So in other words, you could think of a model that we used in our model was that we used JSON Web Tokens for app-to-app communication, and we use OIDC when it comes from the user. No.
You don't distinguish between.
That's right. That's right. We do know which library to use because that's done by the what's called. Let me go back to the JSON Web Token. Yeah, the ISS. The ISS inside a token determines who is the issuer, who made this, right? And the ISS for a JSON Web Token will be a local thing like me, right? And then an ISS for an OIDC will have the actual address of the OIDC server, okay? So that's how we know which one to use and which one to accept. When the system actually gets started, we are told, not we, but the system gets started, Portworx system is told, only trust the following issuers, okay? So not everybody can just log in with Google or anything like that. You need to be trusted issuer. A good question. All right. All right. So before we go to authorization, any other questions on authentication? All right. Okay. All right. So how do you deal with authorization? What's the simplest model? One of the things that Kubernetes does is that it does this thing called RBAC, or role-based access control. Okay. So with those roles, I can give somebody, say, you are the backup role or the snapshotter role or something like that, right? And with those roles, you can get access to a certain number of APIs in Kubernetes, okay? So what we do is that we try to do the same thing, but in open storage, so open storage specific APIs. Okay? So when we say RBAC, I want you to realize that that's just a generic term. Sometimes people get confused and say, oh, you support RBAC, so that means you support Kubernetes RBAC. So no, 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 no. Those are RBACs for Kubernetes for its APIs that are very specific for their APIs. And these are RBAC for our APIs. Two completely different things, same acronym, okay? All right, so let's take an example on the issue between the Kubernetes RBAC and the GRPC RBAC. Has anybody done authorization in this style before with GRPC? Okay, you have? Okay, cool. All right. So, okay, so one of the things that we notice is that Kubernetes RBACs are based on the verbs, HTTP-like verbs that they use. For example, they'll say like, you can put, get, list, delete, things like that, patch on the following APIs. And they all follow the same style, right? Because a lot of the APIs, if you look at the internals of the Kubernetes API server, it's pretty much all that, patch, get, you know, list, and so on and so on. So what we do is like this, gRPC doesn't have that same type of model. They're actually almost like functions you're calling. So it's not the same thing. So we need to come up with something a little bit different. So what we did was, let's take a look at this example here. Route guide is a service. It has two functions, get the feature and list features. This comes from the gRPC website. And what we did at Portworx, we said, well, we can break things down instead of by verbs, but instead we can do services and APIs. Okay, and as you can see here, we have a service called route guide, and the APIs are get feature and list feature. So logically, what we want is something called MyRole, right? It's just a role is a name to a set of rules, okay? And let's call it MyRole, and then we say, okay, MyRole has access to the following services, route guide, okay? And it has access to the following APIs in any of those services, and that one's called get feature. So if you notice, MyRole has access to the get feature, but it doesn't have access to list feature, okay? So when the code runs through this, and it looks at this role, that's not me, is it? And when it looks at this role, it'll look at the rules, and it'll say, you don't have access to do this API, and it'll reject that call, okay? Any questions on this? We're going to go out how this is implemented in a second. I just wanted you to understand the logical view of how we're going to do role management. Okay. Good. All right. Okay. So the way we do this is that if you remember, an interceptor has access to what's called an info.full method. Okay? Info.full method is a variable that's handed into every interceptor that has the slash, the gRPC service, and the name of the service, slash, and the API or the method, okay? So what we did in open storage is that we said, oh, okay, let me rip out open storage API, open storage from the service, rip that out from the name, put everything in lowercase, and now I just have service and API. Pretty much just ripped out the service and API out of the call, and we use that for our information. So it looks like this in Golang. So now I have some default roles in my code, and I can have, again, my roles just like before, but let's look at these services. We have the volume and cluster service, and the API is a star, meaning any API in these two services, okay? So, and again, there's an example there, so you can read like a whole bunch of Golang code, maybe a Sunday night when you're bored. And so it's all here, it's all commented. All right, so let's take a look at, all right, good. Let's take a look at our authorization interceptor, okay? The auth interceptor, the very first thing it does is that it gets the user context from the context. So how do we do that? Because we know that this interceptor is below the authenticator. And what the authenticator did was it authenticated the user, I didn't put that here, but it's on the code, is that it pulled out all the entire claims into a Golang object and shoved that into the context, okay? Just to make it easier for the next calls to determine who this is. So now all we do in this interceptor is that we pull out all the user info that's been placed there by the authenticator interceptor. With that, then we look at the claims and we look at claims roles and we pass in the full method and we let this verify function do everything we just told it to do in the previous slides, which is rip out the service and API for this and look at the roles of what is it that this user can do or not do. Okay. Now, I don't have a slide for this, but I do want to point out that we went back and forth a lot on where do the rules sit. Okay. So do the rules sit in the token of the user, or do the rules sit on the server? All right. So the plus and minus for each. So, for example, if I have a token and all it says is your role is the snapshotter, for example, where is the rules for that, right? Now, if they're on the server, the really nice thing is that I can adjust the rules for that role at any point in time without issuing a new token. So one of the things that we have to remember is that a token is an immutable object, okay? Once I give it to somebody, it has a lifetime, and you'll have to wait maybe a week or however long the token lifetime is to change the rules or change anything in that token. So what we decided to do is we may not be able to or want to wait that long, so we'll put the roles in the system and we'll put a pointer to the name of the roles in the token, okay? So that way I can kick anybody out at any point in time by role. I can take out the entire engineering team, you have access to nothing, right? Go have vacation, right? So that's what you can do, but you can do it on the fly. Now, I do want to show this other thing too, and this is something that we added, and we added this without planning it, but it came out to be an awesome feature. With the interceptor and with all this information, we now have an audit log, okay? And audit logs are extremely important for our customers because what we do now is that not only do we know who it is and where you're coming from, your token, the lifetime, the API you're calling, right? We can take all that information and shove it into the audit log, right? On an interceptor, all right? And when you have the slice, you can click on that and again, spend some time looking at it, at its awesomeness. But again, it's pretty cool code. And it's actually quite simple. All you do is get the claim information, shove it into like Logos or something like that, and put it all in JSON format. 5 minutes? Okay, good. And then put it all in JSON format, and then you can just retrieve it with like FluentD or something else, and just collect it all from every single node. All right. So what about REST access? Okay. So we had this requirement from our chief architect. It says, you can do gRPC all day long, but I want REST access. Okay. I want to be able to do curl and whatever API. Okay. And so what we did was we said, okay, there's this project called GRPC Gateway, which automatically looks at your profile and spits out an entire REST server for it. It takes REST calls in and then changes them to gRPC calls for you, all automatically, and then connects your gRPC server and sends the information accordingly. Okay? The really cool thing about this too is that it supports authorization because it looks at the authorization header, which is a standard in REST, and places it in the metadata of the gRPC call. So to our gRPC service, it doesn't know you're coming through REST at all. We return the objects back through the gRPC model. This gateway changes them to JSON and sends them back. So again, it's quite simple. The only thing that you have to do is that you have to tell it where the endpoint is going to be. So what you have to do is create this Google API HTTP option for your gRPC service, and then you say like /1. I did that, but you don't have to do any of that. But just give it a name, and then you say body star if you wanted to send everything across, or you want it to be more specific. There's a lot more documentation on that, but it's as simple as just that. And then now, when I instantiate the REST server and connect it to my gRPC service, it will be listening on that endpoint for this one call. All right, so I got some, I'm almost done. This is my last slide, but I do want to point out that there's a couple of cool things too about working in gRPC. One of them is that you can generate all your documentation from your gRPC proto file and spit it out in Markdown format. And that's done through that project right there, proto-C gen doc, okay? And I'll give you an example. Well, we do this for our calls, and we can make it look like this. I mean, this is our model, but we have it that it generates all this. So we can go to any of our APIs, and it looks like that. This is all coming from the proto file. So our customers can come here and see everything in a nice HTML format, but they don't have to go to the proto file. Okay? Let's go back to the other slides. All right. And then lastly is, I don't see this a lot being done, and I'm wondering why. Maybe it's just me that I'm doing something, making a mistake. But I feel that we should be versioning our gRPC protocols more, right? And what we do is that in open storage, what we do is that we create some enums and we change the number, right? We forcibly change the number, so that way we can track the version of that protocol from the API server or the client. So now the client can say, oh, I am at 3.215, and the server, when I communicate with the server, I can get its version, right? And they can communicate back and forth. So this is just something on the side, but we find this extremely powerful to determine what versions the systems are at and what version the client is using. We do it by hand. Yeah, we do it by hand. And actually, when we go here, if we look at the change log, you can see every change has been change logged. And we can go back to any version in the SDK. So, all right. And then that's it. Again, those are the slides website right there. And you can reach me on Twitter. And do you have any questions? Thanks.
Question? What?
Oh, using certs? Oh, sorry.
So my question is, what are your thoughts about mutual TLS and
That's right.
TLS?
So using certs for authentication and authorization, pretty much, right? So we thought about doing that, and that works really well when, for example, we wanted to do node-to-node acceptance, right? Communication. But then we thought, well, if we're going to do that, we also need to do this. We needed to do JSON Web Token communication. So it didn't work for us. But that's a good model, for example, etcd. I don't know if you worked with etcd, it uses cert authentication model to be able to have its client be able to connect to the server, etcd server. And that's a good model because there's not going to be that many clients, right? It's going to be just a few. They'll connect, and that's it. So that model, it depends. That's what I'm saying on your model. Any questions?
Cool. Tell you what, one more. Anybody?
Okay. So how do these libraries manage certificate management? And the thing is that certificate management is for TLS connection. Everything that I spoke today was about token management. There's no management of, as soon as you get the token, you throw it out. So you get the token, right, that was created by something else. So you're the service. All you do is look at the token, you verify it, say, okay, I trust this person. Second, say, let me take a look. Actually, as soon as you verify, you say, I know this person, you throw it out. As soon as that's right. The public cert or the shared key. You just have to restart the server with a new information, with a new cert. Does that make sense? So what you have to do is your server, when you design it, you have to make sure that you satisfy the requirements of your deployment. If that is that your public key is going to be around for a year, which is a cert, then yes, you keep that for a year. If it's a shared key in any model, if you have to restart it, then that's on your system. But the libraries do nothing. All they do is take the information. Not really. No. Again, those boot certs are for TLS. The application you have, it's up to you. It's just a library. So you can have it just restart the library process when it reads, like, do IOTL read the cert, the public key. All you have to do is just read it again. Like, you could get a gRPC to say, hey, I gave you a new cert, read it again. Or you can even send a new cert through a gRPC. It's just a binary string. But the ones that recycle a lot, those are for like CA connection, right? Those are for TLS. Yeah.
Cool.
Right.
Thank you very much, Luis.
Thank you.